Hello, my name is Ajay Dholakia. I am back here for our chats around topics in AI. Today, we are going to talk about Agentic AI. And just to set this up, this is something that's come up in customer conversations, in conversations with industry experts and partners quite often in the recent months and weeks. You can read lots of reports in the trade rags around AI agents or agentic AI systems and so on. So, we will spend some time today. Let's break it down. Let's understand what we mean by that, and then this will hopefully help you all to have deeper conversations with your customers. So, going back to the main term agents, what is or are agents? And typically, this you talk about an agent when they are acting on your behalf, right? Something that does something on your behalf. Could be a human, could be a machine. Basically, the idea is that they take care of doing something, and thereby they are assisting you in continuing your process flow or your workflow or your decision flow. Very generally, that's agents. We are interested in software agents, so implemented in the form of a software. And these are also could be, let's say, rule based. If something happens, do this. If something else happens, do another action. So, that's the kind of software implementation that is of interest to us. And we see them everywhere, right? They are in your email programs, they are in your web based applications and so on. What we want to focus on today are AI agents. So, clearly these are software. I am sort of writing them indented to indicate that we are talking broad category agents, then a subset software agent, and then within that AI agent. So, these are software. The interesting thing that sets them apart is learning from, let's say, data. So, when does a software agent get the name AI agent is when they are able to keep learning from the data that they see. And typically what that means is that they are deploying some sort of an AI model. If you recall in some previous Lightboard sessions, we dug deeper into what is a model and what are some types of model. And in fact, we settled on looking at generative AI models such as LLMs, that is the talk of town everywhere you go, individuals, companies and so on, large language models, right? Things like GPT, which are behind the application ChatGPT and so on. So, that's our taxonomy or definitions. Now, why is this important? Let's shift over to the middle part here. It's because these are assisting to do AI driven tasks, and tasks could be some definition of a step that a process flow requires. So, for example, let's break them down into two groups. Simple tasks, they could be, let's say, a Q&A system like a chatbot. You need to know something, you ask a question, you get back an answer. That's a simple task. Another one might be search, where you are looking for, let's say, documents of certain types or certain specific date related or place related information. Those could be simple, I am calling them, because that's one query in, one response out. The other end of the spectrum is a more complex decision making process. So, maybe it involves multi-step decisions. You need to know something and then you need to know something else, and then combining those two pieces of information, a final decision will need to be made. So, those are sort of the tasks that I would put under the category of complex tasks. Maybe they involve multiple data elements, and that sort of lays out the framework for having to break it down. Further complication actually might also come from where the data is. So, data locality might play a role, and this is another very common term that is showing up now, and I would put it out here. You probably have heard a lot about hybrid AI, meaning your data may be in some local repositories or it may be in some public repositories. On your computer local, in your data center local, out in the public cloud public, right. So, that is kind of the hybrid AI setup or hybrid cloud setup that we talk about, and that has an influence on how complex a task is. You might even have to worry about access rights, that is the agent or the human on whose behalf the agent is carrying out the task allowed to get to that data? Do they have the right to access that data? You have to worry about those security privacy considerations. And ultimately, when you have all the elements brought together, some sort of reasoning logic has to be available to piece it together to supply a final decision. So, AI agents can be undertaking simple tasks or in fact more interesting complex tasks, and that is really where it gets very impactful for a lot of our customers, and that is the reason we are hearing from them. I am sure you are hearing from them as well. So, if we then try to pull it all together in this hybrid AI, and let me even say the word hybrid cloud, because we talked about where the data could be and corresponding compute could be, right. So, that could be in a cloud setting. What we are saying is this multi-term system or design, which is that multi-layer agentic AI for complex tasks in a hybrid AI world. That is a mouthful, but we already broke down what's agentic AI or AI agents. We broke down what's complex task, and then we said, well, that's driven actually by where the data is sitting. So, this term, when you just hear it like itself, might be too much, but once we understand the components, we know exactly what the customer has in mind and how we can help them. The only thing I haven't talked about is this multi-layer, and so I figured we can look at this diagram here. And what we are doing there is we have set up, in this case, 3 agents in a 2-layer interaction, right. So, at this layer, let us call this agent 0. Let us give them some number, agent 1 and agent 2. So, what happens is human is giving you, or this agent, some sort of a question or a query or a task, right. And the agent 0 then looks at that and figures out that, oh, in order for me to provide a proper response to that query, it is necessary to access data sitting, let's call this local. Agent 1's task is to go access local data repositories. Agent 2's task is to go get public data. And typically, to simplify implementation, to handle parallel streams of concurrent users, instead of mashing all this in one piece of software, they are set up as multiple different agents. So, that is why we are giving them different numbers. And then we can assign them some sort of specialty, like this agent 1 is good at going and has the access rights to get data in local repositories. Agent 2 has the access rights and the API call capability, etc., to public domain, either applications or data repositories. To make this real, let us look at a couple of examples, and I would even surmise that once we talk through this, you will get a sense that, well, most of what we work on, either as individuals or as enterprises, typically end up falling in this view of the world, or in this model of the world that we are talking about here. So lunch, I say, what does that mean? Let's say the human says, do I have time to go grab lunch at my favorite deli today? Well, this agent gets that question and says, oh, okay, I need to know if that deli is open today, and how far is it, and how long does it take, and which mode of transportation to take. Well, the restaurant schedule, the modes of transportation are all public information. So agent 2 goes off and fetches that bit of public data. Agent 1, on the other hand, has access to the Outlook calendar, for example. So that's local, that's actually just assigned to that particular individual, and is able to look at, oh, there is an hour and a half gap in the schedule around lunchtime. It takes about 15 minutes to get to the restaurant. Yes, they are open. All these pieces of element come back to agent 0. They are pieced together through some sort of reasoning logic, and the response goes, yes, you can go grab lunch at this deli today. Something we do and think about every day, but we maybe not always think about breaking it down in a way that, well, actually we are living in this hybrid cloud or hybrid data world, and if we were going to employ AI agents to help us in making those decisions, we will have to enable them to live in this hybrid AI situation. Well, that was a personal example. How about an enterprise? So let's say that you are a company that offers pharmacies. And these days, at least in the US, you will have pharmacies themselves, or in grocery stores, or in other larger chains, and so on. So multiple companies could fall under that situation. And a customer walks in and says, should I take my flu shot? This is the start of the fall season. Flu shots are being talked about, recommended. Now this human comes in. Why is that a hybrid AI task that could be accomplished using agentic AI design? Well, one of the pieces of information needed is population health data. For the specific demographic of this customer, or the human that's coming into the store, what are the recommended guidelines for taking a flu shot? Could be age dependent, could be gender dependent, could be geographic dependent, could be many factors, right? Could be other diseases and so on that may influence that area, and the recommendation may be very strong or okay if you don't, and so on, right? So that's all public data. You need to get that. Agent 0 looks at the query, sends off agent 2 to get that information. On the other side is the personal record of that human. Did they take the flu shot last year? Do they have some exposure or risk factors, comorbidities, and so on, right? So those are inside patient data records that are very private, personal, and they need to be accessed. And then again, both of those pieces of information will need to be combined to determine that, oh, for your age, for your location, the recommendation is strongly in favor of getting a flu shot, or if you haven't had this in the past, you're okay. Whatever the recommendation may be, you're okay to skip it, right? But the illustration here is to evoke the fact that, again, a simple question like this ended up involving a hybrid AI situation where we can benefit by having this type of an agentic AI design that can help or assist in arriving at the final answer. And you can start thinking about all kinds of other scenarios where this would apply. And I would love to hear from you other examples. But just to close it out, what we are enabling or talking about here is how can AI, and in particular agentic AI, help in implementing decisions for complex tasks in this manner. Hopefully this made sense to you, and what we will do is next time we get together, we can dig into how to implement do we need to use large language models? For example, parsing the question that came in, break it down, get the right elements and access the right repositories and so on. So we can start to get into the design. For today, we will leave it at this level. Hopefully now you can engage much more easily with your customers when they bring up the question around what is agentic AI and how do I make it real for me, and what does it really, where does it really help me? With that, let's call it for today. I will see you next time. Lenovo, Lenovo.